Set theory, example 7. So on the next couple of pages, we have a variety of problems that are questions that are mixed practice from everything we've learned so far. So I would try to do these on your own first before you watch the video to get the answers. So I'll give you some time to pause. Okay, welcome back. Let's see how successful you were with these particular questions. So consider the sets A equals a set of single-digit numbers. So as I said before, sometimes it's nice to go ahead and write these numbers out in set form. List them, I think was the proper word we used. So instead of a description, we're doing a listing. Okay, so sometimes it's just a little bit easier to see that. So is 0 element of set A? Yes, 0 is appearing in set A. Is set B a proper subset of A? Well, we see that it has fewer elements, so that's a step in the right direction. But now we need to make sure that every element in B is an element of A. So 4 is in set A, 6 is in set A, and 8 is in set A. So yes, it's not just a subset, it's a proper subset. Is B a proper subset of C? Well, first of all, we see that set B has fewer elements than set C, so that's a step in the right direction. Now let's make sure that it's a subset. So 4 is the element of C, 6 is the element of set C, and so is 8. So that is another yes. Now D asks if set B is a proper subset of set D. Well, just by the elements of alone, B cannot be even a subset of D because it has more elements in it, okay? And as you see, 4 is not an element of set D. I can't even talk about proper subsets here, so no. Is the empty set symbol an element of set B? And if you look at set B, I do not see that empty set symbol anywhere. Do not confuse element of with subset of, okay? So that symbol, the empty set symbol, is not an element of B, so no. Okay, is C a subset of C? Well, yes. Every set is a subset of itself, but a set cannot be a proper subset of itself. So the answer to this is yes. All the elements 4, 6, 8, and 10 are found in set C. G, they're asking if a set with elements 10, 8, 6, and 4 is a proper subset of C. Well, we see that they have exactly the same number of elements, so that makes us a little concerned there. And we see that we have 10 is in set C, so is 8, so is 6, so is 4. Those are equal sets, so the answer is no. Is set C a subset of B? Well, C has more elements than subset B, so from just looking at that, that's going to be impossible. And as you see, element 10 is not in set B, so that is no for so many reasons. Okay, so I went ahead and I rewrote the sets for the next page so we could have something to refer to. So for I and J, let's talk about the empty set. Now there's a couple of things that we need to remember or that make sense. Let's talk about regular subsets first. The empty set is a subset of every set, including itself. But when we talk about proper subsets, remember they can't be equal to each other. So with proper subsets, which is what I and J are about, the empty set is a proper subset of every set except for itself. Because remember, they can't be equal sets. They can't be the same sets. So then the answer to I is yes, because the empty set is a proper subset of every set except for itself. And J is a no, because the empty set is a subset of every set except for itself. Okay? All right, let's look at K. Is 10 an element of set A? No, I don't see 10 in there anywhere. Is A a subset of D? Well, that can't be, because you look at A and it has more elements than set D. Now, the other way around's true, right? But A is not a subset of D. Is the empty set a subset of B? Yes, I only have to look at B. The empty set is a subset of every set, including itself. So, yes. Is D a subset, a proper subset of A? Well, first of all, set D has fewer elements, so that's nice. And can I find 6 in set A? Yes. How about A? So that is a proper subset. D is a regular subset of C. Okay, well, is 6 in set C? Yes. How about 8? Yes. So yes, it's a subset. Okay, and then is D an element of A? Remember, there's a difference between the subsets and is it an element. So I would have to look at set A, and is the letter D there? No, the letter D is not listed at all, so that is a no.